Alright, so for example 1, unit 2 polynomials. So how can we multiply polynomials? Well,
When multiplying you add and subtract, like all you do is put squares and you multiply.
yeah, we're going to use those kind of tools to do it, right?
Yeah.
So the standard we're talking about is understanding that polynomials form a system analogous to the integers, namely they're closed under operations of addition, subtraction, multiplication, and to add and subtract and multiply polynomials. So don't worry too much about this standard as long as you guys understand the material. Don't worry about understanding that standard.
Okay. All right. Well, thank you.
So.
All right. So I'm going to tune in to your class. Well, I'm also over there.
Okay. Sounds good. Whatever you got to do.
It is, but talk about your mind being crazy jumbled. It's just wild.
Did you get all the right stuff?
I got these two because these
This
two
one
I
we're
can
going to
use.
do later on, and like we're not doing that today, just so you know.
Okay.
You can use it, and then this is what today's lesson is. The lesson in the worksheet.
This one.
Yes, that's the practice, and this is the lesson.
Okay.
There you go. Okay.
Alrighty. I thank you, hon.
All right, no problem. Let me know if you need anything. All right. All right. So let's talk about multiplying like bases.
If I have questions, just ask. Okay. Let's go.
Bye, Mister.
Bye, you.
All right. So multiplying like bases. So the first thing you always want to check when you're multiplying like bases is that your base is the same. So that's the number of which, or the variable of which your power is 2. So do these have the same base? Yeah, they're both 4. So you take the base and you rewrite it. Okay? Now what you're going to do is add those exponents together. When you're multiplying like bases, you add the exponents. So what's 2 plus 3?
5.
Very good. Everybody with me on how we got that one?
Yeah.
So we multiply like bases. Here we're going to add the exponents. Now remember, the bases have to be like in order to do that. Now what about the one below it? What do you think the answer is here? Y to the 8. Good job.
Yep, I got it.
You got it? That's good.
The x squared 7 times x 5, like, or you just put x and 7 plus 5 equals 12.
Correct. X to the 12. You add them together.
Is like,
That's, you have to multiply the
You so whenever the base is the same, you rewrite the base and add the exponents. Now in this case, do we have the same base?
No.
No, so we can't do anything with that. We just leave it. Okay, if you don't have the same base, you just write them next to each other, okay?
x.
Not bad, right?
So like, you basically just drop it down and you can't do it.
Yeah, you can remove the multiplication sign because remember in math, just putting something next to something, as long as it's not,
Multiplying it.
means they're multiplying. As long as it's not like a number, obviously you can't do that with a number. But yeah. Do you have any questions on this slide? Okay, it's not too bad. That's like my favorite thing.
I got it yesterday at the store. Cause I was looking like for my friend, and then like I saw it and I was like, okay, I'll get it. So it's actually really good.
It is, yeah, they have like a lot of good flavors. The watermelon one's really good too.
I saw that one.
Yeah, it's so good. Alright, so now we're going to talk about multiplying monomials and binomials. So, I know this is a monomial because it's a single term, and this is a binomial because there's 2. So we multiply these using what we call the distributive property. Okay? So you're basically going to distribute like this. So what's x times x?
1.
2x.
Not 2x, but
1.
x to the
X.
Second power.
to the second power. Because you have 2 x's and you're multiplying them. When you multiply 2 x's, it's x to the second. And then what's 4 times x?
4. 4x.
4x. And that's all it is. That's all you got to do. Alright, let's try the next one. So the next one, we're going to use the distributive property again. Okay? So, what's 5 times 3?
15.
15.
Good.
Squares.
And how many m's do we have?
3.
Good.
The
15.
third power.
Yes, m to the third. You got it. And then what's 5m times negative m?
Negative 5m.
Negative 5m to the,
1. I
well,
mean,
we have 2 m's to the first, so we have to add the
oh,
exponents.
2. Yeah, 2.
Yep, to the second.
And then negative 35m squared.
Can you explain to me how you got 5m?
Sure. Alright, let's talk through each term and how I got it.
I understand the first one.
He
Would
actually-
negative 35m be squared?
No.
No?
So I'll talk through why. So the first one, whenever there's just an m without an exponent, the implied exponent is 1. So you can put a little 1 on it to help you like understand what's happening.
I see.
We add the 1 and the 3, the 1 and the 2 and we get 3. Okay? For the next one, this right here is just a negative 1 in front of this m. Negative 1 times 5 is negative 5. Now for the m's, I have to add the exponents. So 1 plus 1 is 2. Now over here, I multiply 5 times negative 7, which is negative 35, and there's no m here. So I'm only keeping this m right here. The only m I have is the first m right here, which is just m to the first. Okay? Does that make sense? Alright. Good job. So the last few we're going to talk about. So let's do the first one together. So,
A to the second power.
good, that's the first term. And then what's the next term?
Negative
9k.
9x.
You got it, negative 9k. Don't forget your negative sign. It's not bad, right? It's not too hard. You guys can do it. Alright, let's look at number 2.
So it would be 9a squared.
9 to the second power.
The 9's not to the second power, but
Negative
the
2.
a
It's the
is to the
variable.
second power.
Feel like
It was,
E, that's what I meant.
9a.
9a to the second power.
Alright, that's good. I just want to make sure.
I just need 9 too. I knew the first one.
Alright. Do you guys get this one too?
That's
9. Plus 9, how is it plus 9?
Oh, at the end? Oh, 9a. I know. Now you get it? I got distracted, everybody was talking. Alright, this one here.
Would that be negative 6p to the 3rd?
Mhm. Plus 48p. Because remember, when I have just the p, it's to the first power. Like basis, add the exponents, number, just one number, multiply here. Negative times a negative is a positive. There's only one p, so that's that. And then the last one, we use the distributive property here. We get negative 6c to the,
6.
good,
Dang it. Good job.
minus
Uh, 15c.
15c
to the,
Good.
and that's how you do it. So I will hand out your worksheet. Yes.
Would you ever, would you ever combine those to like combine like terms or?
You can only combine them if they're like terms, and we haven't had a situation where they are. If they are, yes, you can.
Well, aren't those like terms?
Like terms have to have the same variable to the same exponential power.
Okay, so if the 5 was a 6, then you could combine them. Okay.
Yep. Yep, remember like terms have to be same exponent, same power. Not the same coefficient. Coefficient can be different. Alright, so I'm going to give you your worksheet. We'll get through the worksheet, and then maybe we'll have time at the end for a math hangman or something. You guys